In this presentation, we're going to look at subsets and elements of sets. So first off, let's look at the elements of a set. Sets are comprised of members which are often called elements. So if we have a particular value, let's say k, and it's an element of set A, we would write it as follows. K is an element of A, or we could say k is in A. Now, if a single value k is not an element of A, then we would write k is not an element of A. So that sort of symbol there just gets a line through it, that element symbol or in symbol. So that's how we would write an element. So k is an element of A. So I have a little example to sort of discuss that later on. So I'm just going to come back to that now. So given two sets A and B, the set A is a subset of set B if every element of A is also an element of B. And we would write this mathematically as follows. So A is a subset of B. So that's a subset symbol. And that's distinct from the element symbol that I've used previously. Now, just a quick remark on something. Sets are denoted with curly braces even if they contain only one element. So I'm just sort of using that to lead up to an example here. So suppose we have a set A comprised of the following elements. A is comprised of 3, 5, 7 and 9. The value 5 is an element of A, so we write it like that. 5 is an element of A. The single element set that just contains one value 5 is a subset of A, so that set that contains only the value 5 is a subset of A. So just a little bit of a distinction between the role of the two symbols, the element symbol and the subset symbol. So that's the key point coming from this presentation. But I just have a few more remarks to make. A proper subset, if we have two sets A and B, and the set A is a proper subset of set B, if every element of A is also an element of B, but there are no elements of set B that are not in set A. So we might write that mathematically as follows. A is a proper subset of B. I'm just going to go back here a second just to sort of show you the distinction here. 5 is a subset of B. So it's that bar there. Now that's a sort of like an equal sign. In this example, actually, 5 is the single element set 5 is also a proper subset of A. So we could have used the other symbol. So that's a proper subset. There are elements of B that are not in A. Now, equivalent sets. If both of the following statements are true, A is a subset of B and B is a subset of A, then the sets A and B are equivalent sets. That means more or less that the A and B are identical to one another. So that's just a useful little remark. Also, what we might have is non-comparable sets. If both of the following statements are false now in this case, A is a subset of B and B is a subset of A, then the statements then A and B are said to be non-comparable sets. Okay, so just a few extra definitions there: proper sets, subsets, equivalent sets, and non-comparable sets. And that ends our presentation.